Hey there, Professor Poggy here. I want to have this quick video to show you how to do the mean difference, or compute a 95% confidence interval for the mean difference. Okay, so let's share my screen. I already have here, this is the exercise, and I'm not going to do the whole thing. I just want to show you the steps involved in doing this. Okay, let's look at this exercise. It's about water fluoridation. The study looked at the number of cavity-free children per 100 in 16 North American cities before and after public water fluoridation projects. If you're familiar with this public health strategy, adding fluorine to the water helps with oral health. Okay, and so the table below lists the data. You will need to manually type the data into StatCrunch to use that tool to calculate the requested information. So remember, in StatCrunch you can simply update the name of the variable by clicking on it and typing. So we want to add the after. I'm only going to do the 5 observations here. So 49.2, make sure you do enter all 16, okay? 30, 16, 47.8, and 5, 3.4. Same thing for before. You want to do 18.2, 21.9, 5.2, and 2.8. Okay, so again, you're going to go down the list to enter the data for 16 cities. Then it tells you calculate delta values after minus before for each city. There are many ways that you can do this. A simple way is simply going by date in data, compute, expression. You can build the expression and say after minus before, okay, compute, and then you're going to have it right here, okay? You just simply 49.2 minus 18.2, it's 31, okay? So you're sure about that. You can also change the name of after minus before to delta if that's something that you feel comfortable with and understanding. Remember, looking at the data is not just inputting the data and running the analysis, but really understanding and interpreting the results, okay? So public health specialists, healthcare professionals, they're working on this research to make sure that the number of cavity-free children per 100 increases, right? Because this is a prevention strategy. So the improvement is going to be measured by positive numbers in that delta, because after minus before, the change, we want to increase that number, right? So after that number at the end, we want to have more free cavity-free children, okay, after this strategy is implemented. So that delta is going to be positive if there was an improvement in that particular city, okay? Then you're going to construct a stem plot. You know this from Module 2. Or a box plot. You simply go into graph, stem and leaf, select the variable, and compute. Okay, remember, we're going to do that for all 16 cities. Or if you want to do a box plot, you graph box plot, select the variable, and compute. Okay, so that's the box plot and stem plot. And what percentage of cities showed an improvement in their cavity-free rate? Again, we want this number to be positive. So you're only going to look at those that show an improvement or that where this delta was a positive number. You can manually do that, it's only 16, or you can create an expression where delta is greater than 0, and then you're going to have a number in there, okay? And then the last question, C part is, part C is estimate the mean change with 95% confidence, and it's telling you to compute a 95% confidence interval for the mean difference. And here is the interesting part. If you look at the data, you have dependent samples, right? you have a before and an after for the same observation. For the same city, you have two measurements. So you can simply go into stat. We're going to complete a t-stat. Why is that? Well, we only have 16 observations and we do not know the population standard deviation or sigma, okay? So you're going to do t-stat. You can do pair t-test. You do sample 1 after, sample 2 before, and then you're going to do the confidence interval for that mean difference, okay? And you're going to do compute. And here you have that 95% confidence interval. However, you can also do the t-stat, one sample with the data, but then you're only going to choose that one variable, okay, which is delta. And then you're going to do the confidence interval and compute. And then you will notice that it's going to give you the same results, okay? At this point, it's up to you. What matters here is that you do understand what the result is. Here, it's giving you one sample t confidence interval. It's not really one sample where you're looking at delta, okay? And for that reason, to me, it's easier to comprehend and understand that you're looking at the pair t confidence interval where you're looking at the mean difference, okay?